All right, so let's go ahead and do that. There is a link, if you're following this on app.fivable.me, there is a link in the down below to this question if you want to just look at the original text of the question itself. Okay, what I'm going to do now is switch over to my tablet, and we're going to work them. I'm going to mostly be typing, just to illustrate that you can type most of your answers to this if you want. All right, so I do want to give you a few seconds just to look at the information that's in the problem stem, and then I'm just going to go. Okay. It's believed that this can be completed in 15 minutes. I probably won't get to it quite in 15 minutes with some of the commentary I'm going to put in. But as you look, just understand a few things and just a few reminders. Make sure you're comfortable with whatever method you want to use to submit answers before the day of the exam. Some of you have probably already taken some AP exams already, but if you have not, make sure there's a bunch of tutorials and overviews about it. But the two main for math exams, I would either say prepare 5 pages with your AP ID and just write your AP ID, your initials, and number the pages ahead of time. Handwrite, take photos, make sure that you've got the live mode turned off on iPhone so that they come up as JPEGs instead of HEICs if you guys are using iPhones. You can or you can type. I think there's a lot of typing you're going to be able to do on this one. Okay. All right, so let me not distract you any further so you can see the wonderful thing. I'm going to go through the prompts first, and I'm going to build on a little bit, and then we'll go to some of your Q&A, and then I'll go to the other mock prompt if I have time. Not product placement. Okay, so you see just a description of the study, and you see a set of statistics here. Let's just go question by question, and then let's ping back and forth to the description. So the first prompt, explain why the yields from one type of corn are not independent of the yields from the other type of corn. They're being very nice here and telling you that the GM and regular yields should not be independent. And so the information is definitely somewhere in the stem. Okay. And so when we say not independent, what we really mean is that we're expecting there to be some association. Okay. So overall, what we're looking at here is, let me see if I can, let's put my stuff in bold. We expect there to be some association between corn grown on the same plots of land. Someone's pointed out that both crops are grown on the same plots of land, right? Since both types of corn are being grown on each plot, we would expect the corn variety in 1/2 of a plot to the corn variety, the yield, let's put the yield, that's yield of the corn variety in 1/2 of a plot, to be related to the yield in the other half. Okay. That's like the bare minimum, I would say, for your answer to this question. Some other things to consider, for example, are issues involving the actual quality of the soil. So someone asked, can you justify by saying that this would make it a matched pairs design, which applies independence, and everyone asks that. I would say that you could say that it's a matched pairs design because of the study design. They actually took each plot and divided it in half instead of just randomly selecting plots into different locations, for example. That's what I would say to that. I would think that this reason comes first before the fact that it's a matched pairs design. But you do bring up a really good point that I was going to come back to later, that it is a matched pairs design. And hopefully everybody can see why it's a matched pairs design. Basically, this is a block experiment where the blocks are plots of land. And so you're going to randomly assign one half of each of the plots to each of the types of corn. Okay. Next question. Based on the summary statistics, would it be more likely to obtain a yield of 123 or more bushels per acre from a plot of GM corn or a plot of regular corn? Okay. The answer here is pretty clear, I hope. She's saying, so I said weather conditions and soil types between the parts of the plots make them dependent. Yeah, I could say, yeah, that would be a good addition to this. Like, for example, like they experience like the different soil or different conditions. I don't know if that clarifies it. Yes, thank you, Neil. Okay. So here in part B, I hope it's pretty obvious that the GM corn does better, but the question is, what will your justification be? Okay. So part of it would just be recognizing that looking at the mean and the median, the GM corn does better. Okay. So basically, since, and we're just asking about more likely. So since 123 is less than the median yield for the GM corn, there is an over 50% probability. Well, there's a question about whether we're talking about the sample or the. I don't think we need to go there, but we can say that let's say this: over half the plots in the over half the GM plots in the sample yielded more than 123. What's the unit? I like to know the unit, bushels per acre. And similarly, since 123 is less than the median for the regular corn, less than half of the regular corn plots in the sample yielded less than yielded 123 bushels per acre or more of corn. Therefore, we expect the GM plots are more likely to yield 123 or more bushels per acre in general. Okay. And so we're trying to connect the what's happening in the sample to what's going on in the population. I see a new question. I just want to make sure that. All right, I'll come back to that. Good. All right, so here's a box plot of the differences. And so they're helping you a lot with this. They didn't show you the box plot of the two populations. They showed you a box plot of only the differences. Okay. And so I'm going to just take this box plot at face value and describe just the distribution of what I see there. All right, Neil asked the question, could we use normal CDF as justification for B2? You would actually have to know that the yields for each acre followed a normal distribution in order to use normal CDF. So you can't use normal CDF for that. Now, if you're saying that, well, n is bigger than 30, what's important is that n is bigger than 30 justifies that the sample mean will be a normally distributed sampling distribution. Okay, but that doesn't say anything about the population of possible GM yields under these conditions. Okay, so that population is unknown to you, so you can't use a normal on this. So don't get the conditions for inference about the mean confused. Yeah, that's a good question. Describe the distribution of differences. And those of you who have asked questions in the Ask a Question, those are more general, so I'm going to get to those after I do this. All right. When you check conditions, all right. We ask when do you know to check conditions? You check conditions when you want to do an inference procedure of some kind. So you check conditions when you're about to build a confidence interval or when you're about to run a hypothesis test. Those are the times when you check conditions. You also want to check conditions if you're being asked a question about the sampling distribution. Okay, and someone has a question about theoretical sampling. I'm going to try to get to all of those again. Is that work for you for now, Katie and V? All right. Describe the distribution of differences. So this is a box plot, right? So if you've seen one of my students before, you know that when I do this, what I do is I call it cuss. I cuss in context. Median yield is 3 bushels per acre higher for the GM corn. Unusuals, there is an outlier difference of approximately 20 bushels per acre in favor of the GM corn. And because this is a box plot, we're pretty sure you're not going to have to draw a graph. But if we give you a box plot that shows an outlier, you should be able to interpret it. And so I see that single dot at the end, which indicates to me an outlier. Okay. Now the two S's are spread and shape. So let's do shape first. The right half of the box plot is longer than the left half. So the distribution of differences is fairly right skewed. Then if you want, you can say since the right half of the box plot. That includes the outlier, by the way. And then spread. And by the way, when I wrote these down, I'm making sure to include a little bit of context. So like, for example, I'm going to underline the part here that's related to the context. So when you're describing a distribution, you should be, or of any kind, really, you should be adding context. And finally, the spread, you could say, like, for example, you can actually go back to the statistic here, excuse me, and say, like, the interquartile range of differences is 6.9 bushels per acre. And then again, that's GM minus. And here it's okay just to write these numbers down because you've been asked to describe one distribution. And so what's happening here, imagine if most of the data is in the center. I want to emphasize that I do not know what this distribution looks like, but it looks like most of the data is in here. So like if I were to draw a dot plot, whatever is going on, most of the data would be in here. There'd be a little bit of data out here, but there would continue to be some data all the way out here. Right? This whisker indicates that there's data out here, but most of this line where the median is indicates that most of the data is clustered somewhere in the vicinity where that splits. This line gives you half 50% on the left and 50% on the right. Okay, and you have this one little dot out here. Okay, I'm idealized. You might say like, well, it looks kind of like that, right? But I don't really know that that's what it looks like. So I'm trying not to say too much. Okay, the students conducted a test of the hypotheses where mu sub d is the population mean difference for plots similar to those used in the study, and the conditions for inference have been met. One of the conditions for inference was that the sample sizes, the differences, is greater than 30. Okay, so now we have conditions. Okay, and checking this condition, when you have the sample size of the differences greater than 30, and you're testing for a mean, the sampling distribution of the sample mean is approximately normal if the sample size is greater than 30, which it is here. Thus, we can conclude that the observed mean difference comes from a distribution that is approximately normal, and use a normal model to compute a p-value. In this case, it's actually, I should say it's actually a t. It might be actually that we should probably say t here because that's going to probably confuse things. And the reason it's a t is since the true population standard deviation is all right. So yeah, there's a lot of talk about what we think is going to happen with conditions. We think we think checking conditions is probably in play, but it is probably more likely that you'll actually get a question about this because they don't have multiple choice questions this year. Okay. A t-test only works if the underlying sampling distribution is normal. It's built on that assumption. And that's kind of a interest that the mathematics of t are built on z. Okay, finally, the test resulted in a p-value of something very, very, very small. Okay. Since this p-value is far less than any typical cutoff for alpha, which I guess usually alpha 5. And by the way, if you're, they have a typing guide for symbols like this. Yeah, I think if you just write alpha, you're probably fine. The students should reject the null hypothesis. They have convincing evidence that there is a difference between the average that there's a different that there is a difference when the two between the yield when the two types of corn are planted on plots similar to those in the study. And because it's let's do average here, or mean. Just to indicate that we know what the parameter is. Okay. Convincing is an interesting word. I do want to. Someone is asking about convincing. I think convincing. Here's the thing about convincing, right? Understand that when you run a statistical test, you never really know whether you actually found the truth or not. All you have is evidence in one direction or the other. And if you basically, you can say that we did a great study, we designed it really well, we did everything right, we found a difference that was so implausible that we had to reject the null hypothesis. It would be really logically weird for us to continue to believe the null hypothesis when an assumption that the null hypothesis is true gave a result that has a 0.03% chance of occurring. The only way you can really be sure is to go in there and find a genetic explanation for why, right? The statistics tells you that almost certainly there's something going on there, that there is a difference. But remember that numerically, all you've got is association, right? The way that the experiment itself is structured tells you that the types of corn are responsible for the difference that you observe, because that's the only thing that's different. Okay. All right, so let me get to some of the other questions that are in the Ask a Question. Then we'll talk about interpreting the p-value in context, Steph. So we're gonna do that. Peter, graders will generally be pretty specific about word choice. Okay. All right, so let me get to some of your questions here, because I think that's super important, right? Okay. All right, so the first question is when to use binomial and proportion in a problem. Okay, so he asks this question. All right, so let me go ahead and let's put it up here. Okay. And I could use a little bit of clarification too. I'm going to start talking about binomial and proportion. Okay, but so when to use binomial proportion. All right, so a binomial is a specific kind of thing, right? So when I see the word binomial, I think the following things. I am counting the number of successes in a process that is executed or is done a fixed number of times with a fixed chance of success. Okay. And then the number of successes will be binomially distributed. Okay. In this case, I could post this after the fact if you want. Okay. Yeah, if I can't, I'll do it afterward. Okay. So what you're looking for in a problem when you say, oh, this should be a binomial question, is do I need to know the probability that something happens X out of Y times, right? So I see for example, what's the probability of seeing 4 dead trees in a survey of 20 plots? Okay. And then I'm going to ask myself, maybe this is a binomial case. If I know that there is a percentage of dead trees in any given plot, then this turns into a binomial question. Okay. And so for some teachers use bins, and so you can actually see that what we got B is there's a binomial process going on, okay? Because what it says is there are only two options: success will be called success or failure. That's the B. That's binary. Okay. Independent is important too, and so here I'd have to ask myself whether the trials are independent of each other, whether these plots are independent of each other. And in this case, if I'm surveying 20 plots without replacement, that tells me that the 20 plots have better have been at least 200 plots for me to choose from, or I'm not going to feel comfortable that these 20 plots are going to maintain the same fixed probability of success. Because if it's 20 out of 50, then as I start drawing plots out, then we're going to see a problem that you start changing the probability as you pull more and more of those plots out. Okay. A fixed number of trials, that's the N. And then and there you go, a fixed chance of success. Okay. And that I'd have to know what the chance of success is. So that's what some teachers do. Now the binomial is kind of fun because the binomial distribution underlies the proportion sampling distribution. So all the techniques you learned for binomial, for example, you learned that the mean of a binomial distribution is NP, right? Well, what that tells you is that the mean of a sampling distribution of a proportion is just P because it's NP out of N. But the process is called flu. The process is just called a set of Bernoulli trials. Yeah. It depends on which book you learned it in. Okay. So all of the numbers, I would say, Katie, I would really say not. You can. It depends on how you structure it. There's actually this one review course I was working through that I solved using binomial, and I got an answer that was not the intended answer because they were using the sampling distribution for a proportion and a normal model, whereas I was using binomial, but the two things are really the same thing. So I actually want to warn you then that, for example, let's say that I want to know the probability of getting 10 yes answers out of 25, where the probability that someone would say yes is actually 0.5. Okay, so binomially, getting 10, getting at most 10 yes out of 25. Okay, so I'm going to kind of do a stat teacher bad thing here. I'm just going to say I'm going to use BinomCDF, right? And so there's a difference here. When I say at most 10, that means that I want to know the probability basically of this is P of 0 successes plus P of 1 success plus 2 successes plus all the way up to 10. Okay. We don't think this is going to be a heavy calculator year, Narun. So we're not real excited. It's something that requires knowledge of how to do this kind of computation super well. But I'm just trying to answer this as a thought question, basically. Okay. So the probability of getting at most 10 yeses out of 25 where p equals 0.5. So I can use Binomial to do that. I don't want to burden you with the calculator command, but it is Binomial would give you 0.2122. Okay, but this is also the probability of p hat less than or equal to 0.4, right? When p equals 0.5 and n equals 25, right? So assuming that the sampling distribution is approximately normal, which it should be for n, this is another conditions here. N is 25, p is 0.5. Both np and n1 minus p are both larger than 10. So we feel pretty confident that this sampling distribution is approximately normal. And so the probability of that is, I'm going to do another bad here, or I'm just going to use NormalCDF. I'm going to use negative infinity 0.4, where we have 0.5, and then we need the mean of the sampling distribution. The meaning of the sampling distribution of sorry, that was a confidence interval snafu there. Okay, so in this case, we get 0.5 times 0.5 over 25, right? And so 0.5 times 0.5 over 25, 0.01 square root, and that is 0.1. You could say that I made that number work out perfectly for whatever reason you want. And if you see that, you already know from the empirical rule that that's going to be about, because if 68% is in the middle, then 16% is going to be in either tail. So this number should be about 16%. Okay. These numbers are very different, but both approaches are valid. Okay. Which I know sounds really dumb and really confusing. So that's the important moral of the story for you here is show your work. I would, on the AP exam, accept either answer as long as you told me how you were getting it. Does that make sense? Okay, so that was that's binomial proportion. It's I know that was, yeah. There's a lot there. I know there's a lot going on there, so thanks for hanging in with me there. I'm glad that helped. Okay. Is there a preferred method of randomization? Like it is best to put numbers in a hat or use a random number generator? Unless they tell you something in particular that you're being forced to use, do the simplest thing possible. Okay. My go-to is to just use slips of paper and numbers in a hat. That to me is honestly, that to me is my go-to for randomizing things. It is much, to me, it's much more important that you just have a method that works. They don't really care which way you do it. Now, I'm pretty sure they're not going to ask you to spend a lot of time describing a randomization process. Okay. But that's a great question. Honestly, do what you're comfortable with. If you're really comfortable answering questions with a random number generator, knock yourself out. I think that's great. I just do numbers in a hat because I don't want to think about like I need to assign a number from 000 to 999 to every subject. I don't want to. That's too much thinking, right? The slips of paper also lets me just write like the names of the treatments for an experiment, for example. I think the slips of paper version is much more flexible than a random number version. So unless you're being forced to answer in a particular way. Okay. I'm gonna hit some quick hits here. I strongly doubt you will have to construct a box plot or graph. I am not on the test development committee. I do not have a crystal ball, but my thought is that would be really, really a difficult question to ask students to do, given the resources they have, the number of different kinds of things that might be possible in people's situations. If people want to just type their answers, if forcing people to box plot or graph in a situation where we pretty much just typed every answer to the question we just asked. The minute I ask you to do a box plot, that's out the window, and everyone's going to have to handwrite. So I really don't, I'm not expecting a graph or box plot on the AP exam. I don't recall having seen an official word. I know for calc, they officially said no one was going to have to graph. And my thought is that that would be what's happening here too. You guys are doing a great job answering each other's questions about Binomial in the chat too. So I appreciate it. Okay. Let's see. Okay. Katie, I was going to say the same thing that Neil said. They did give you a backup now to email your response if the submission fails. My advice is just to make sure you're submitting the right kind of file. Just make sure that you're well practiced in it. And this is not ideal by any stretch of the imagination. And I'm really disappointed for those people who have worked very hard and their technology costs them, or at the very least inconveniences them, if not outright costs them a chance to submit their answers on the exam. But there's very little that can't be done about that. Okay. Rejecting the null hypothesis. So Olivia asks, rejecting the null hypothesis means that there will be convincing evidence. Yes, when you reject the null hypothesis, you do it in the face of convincing evidence to do so. The p-value is always computed with the assumption that the null is true. That's where you get the shape of the sampling distribution, is by using the null hypothesis. So when you get something that is so far away from the hypothesized value on the curve that you've drawn, like if you've drawn a curve here and the answer is like over here, very far away from the center, that's convincing evidence that you either got super duper unlucky, which is not likely because you have a probability for how often you see things like that. That indicates to you that your assumption about what's undergirding the null hypothesis is less reasonable to hold than the alternative. Okay, so we are rejecting the null hypothesis when what that goes hand in hand with a low p-value, therefore convincing evidence. You have convincing evidence that the null hypothesis is an unreasonable. Okay. I do want to answer this question about, can you copy a picture of your work on paper and paste that into the Word document you are typing your answers in? Ashish asks. My understanding is that doesn't work. Okay. That doesn't work at all, unfortunately, when you submit as a PDF or Word. Now, I do know that they said that for the calc exam, you could scan all your images into one PDF and submit that as a text file, but that the implication seemed to be that it had to be all images. Okay. So I would say no. I would either do it all on paper or all text personally. I just don't know how that's gonna translate. I guess I'll find out this year because I'm reading this year, so that'll be really fun. Okay. Just COVID the flu. Can you tell us about theoretical sampling? I would love some more clarification on that particular question. However, pros and cons of pooling. Oh, pooling. Pooling. Okay. You pretty much for a 2 mean test or interval, don't pool. It's just they're not gonna give you any situation here where you should assume that both populations have the same variance. That's when you pool. When you do that, when that is true, you get a slightly the estimate is slightly better overall, but honestly, you're not going to see that, and you don't need to make that assumption for anything on this test. Now, if you're talking about the pooling or the pooled proportion that goes into a 2-prop Z, well, that's exciting and different and weird. The reason that you have a pooled proportion is because you're assuming, like, look at the null hypothesis, for example. this is independent of any context. The null hypothesis is that P1 equals P2, right? And so the another way to say that is that P1 minus P2 equals 0. So if I'm building the if I'm building the normal curve for this case, then I have a dilemma, right? Because I know the center of the hypothesized distribution of P1 minus P2 is going to be the difference between two normal distributions, right? I believe that P1 and P2 have the same center, so I know that they should have the same, the difference between P1 and P2 should on average be 0, but I don't know what the standard deviation should be. And so that's what this formula on the formula sheet is for. This is a pooling type thing. Because you're assuming that the two you're assuming that the two proportions are the same. Okay, but that's a different kind of pooling. So never, and you're doing the two sample t-test or interval, never pool. Always no. There's no reason to use anything else in this class. Okay. All right. Okay. Let's see. Other things. I had a homework question asking me to make a mosaic plot. How do we do that? My teacher never went over it. Okay, so let me read that again. All right, so Steph asks, I had a homework question asking about a mosaic plot. Okay. I love mosaic plots. I'm really a big fan of them. I think they're pretty cool. Okay, so let me show you a quick example. All right. To me, what you basically do is start with a stacked or segmented bar chart. Right. So let's say just for ease of use that I have these proportions, right? So this is category A and this is category B. So this goes all the way up to 100%. Okay. Excuse the scale. The scale is bad and wonky and terrible. But hopefully the ideal will carry over. This is a normal segmented bar chart, and the bar charts have the bars have the same width, right? To turn this into mosaic plot, the only other piece of information I need is how many things are in each category. So let's say that there are that A has these proportions, but in group A, I'm only looking at 20 items. And in group B, I'm actually looking at 80 items. That indicates to me that in the mosaic plot that I draw for this instead, I should have a situation where the vertical axis is exactly the same as the stacked bar chart. The vertical axis, let me just make that a little closer. The vertical axis is exactly the same as in the stacked bar chart, but I am going to attribute attribute a bar that is 4 times wider. I'm going to eliminate these tick marks in a second once I've drawn it. I'm going to attribute a bar that is 4 times wider for A than for B. For B than for A, excuse me. I said it backwards. I drew the right thing. I said it backwards. This test is open note, but you do want to make sure you're downloading all the stuff. Like I don't know what you all have heard, but they've talked about like if you are like pulling down stuff from like Google Drives or shared things where people are able to communicate, they're going to be real suspicious. Okay. So print out a lot, like all the stuff that you really, really want to use, or download it to your computer before you start so that you're not accessing something shared. Okay. So this is the mosaic plot. all it is I took the segmented bar chart and I just made the bars like equal to the width of the things that of the groups, the total amount in each group that they represent. Okay, so this is a 1:4 ratio of width because there is a 1:4 ratio of ends in the different groups that you're looking at. So that's how I would go from a mosaic plot. I'd start with a segmented bar chart and then turn it into a mosaic plot. Okay. And so basically what you're doing here is you just want to take the percentages. So like this is 20. So basically this is 20% of the bar of the total width of the plot. And this is 80% of the width of the plot. And then you want to take those and just translate them over here. Okay, so Steph, hopefully that answers your question. Okay. Let's talk about the formula sheet a little bit. I don't know if you guys were here for the stream about getting the most out of the formula sheet. What I'm pretty sure isn't going to happen this year is a whole lot of concentration on things like the regression line, like the R being R SY over SX. That's probably not going to be part of it. The formula that leads to the correlation, the formula that leads to the standard deviation, those probably aren't going to be a huge part of it. The probability rules could be helpful to you. So those probability rules that are listed on the in that one section, those two formulas with like P of A or B equals P of A plus P of B minus P of A and B. I think that's going to be useful to you at some point. I'm expecting there to be probably at least a little bit with conditional probability. You might have to do something in a two-way table, right? And so knowing a conditional probability is going to be super helpful. So I think those formulas will be helpful, but I don't think unless you're talking about this guy, unless you're talking about the P sub C formula, which is on there, which you may need to check conditions for a 2-prop Z. I don't really think you're going to get a whole lot of mileage out of the backside of the formula sheet personally. It reminds you of a few helpful things, like the structure of a confidence interval. Remind you of that. That's pretty helpful. I do think the formula sheet has some use, but it's probably not going to be as useful as it has been in the past. Okay. Wow, this chat is popping off. It's just like, wow, guys. Pretty cool. Okay, so I hope that answers that question. Let me talk a little. I want to talk a little bit about paper or typing being better. My personal opinion about this is that you're probably going to mostly be able to get away with typing this year. That's my own personal opinion, not official. If you think that I am off my rocker, or you would feel more comfortable writing so that you could make all the symbols that you needed to, please, absolutely, 100%. I encourage you to do that. I think you're going to mostly be able to type, to be honest. Okay. Can we actually, let's see, Neil asks, can we actually write out subscripts or superscripts, or do we have to use the format they put on the keyboarding sheet? I would do whatever they tell you to do, but let me pull up the keyboarding sheet. Yes, I am Googling it right now. I haven't looked at this sheet in like a week, to be honest. So I've pretty much forgotten like everything. I've pretty much forgotten everything that's on the sheet. As long as my internet cooperates, we'll be good. Okay, here it comes. Yeah, so my guess is that if you type like Q _3, they'll understand, right? The main thing is just like if you're going to do a confidence interval, for example, use words to describe it or use interval notation. And so just be pretty careful about that. I think the tip sheet does a pretty good job of just saying, like, I would just do like what, like, I use underscores all the time to represent subscripts. For example, I use the shift 6, this guy here. This guy here is what I use for superscripts. You can also use it for hats, but I think what they want you to do is, and on the exam, looks like they want you to type p hat, and that's what I would do. Like, I would not do, because that could be referred to as a that could be a problem. Yeah, like, for example, if you happen to have to do a regression equation, I would write y hat, or predicted y, like that. Oh man, lots of great questions. Theoretical sampling. Did that? If you clarify that question for me, I kind of missed it. If you could just throw a comment in there. Otherwise, it's really just. Are you talking about? Are you talking about bootstrapping? Yes. Well, the good news is you don't have to know about bootstrapping here, but there is bootstrapping is beyond the scope of an AP course in general, but it is kind of cool that you can learn something about the population by that your sample comes from, no matter where the sample comes from, by just repeatedly drawing samples out of your sample with replacement. Okay, so bootstrapping is, I'll just type it because it's kind of important to know. Bootstrapping is equal to, no, let me do it in the document. Yeah. So this was the 2019 Q6 was about bootstrapping, which is you can learn something about the original population your data came from by sampling from your sample with replacement. And I would not tell you to really worry too much about it, because it is not. There's no way they would ask you a question about that this year. But that's the limits of bootstrapping are. I forget the formulas because I never actually, like, outside the context of that question, I've never really studied like the theoretical limits of bootstrapping. So, I forgot. Okay, so yes, theoretical sampling. What we're doing, that's this question about bootstrapping here. And so basically, you can estimate some of the parameters of your original population, not in a great way necessarily, but it's kind of interesting how well it works sometimes by sampling from your sample with replacement.